Section P6 is titled Rational Expressions, and it's going to use a lot of the things we did in Section P5 that I know you haven't practiced yet, so I do apologize for that. But a lot of those factoring things that we did are going to actually be utilized now. And we're going to utilize them to simplify rational expressions. So first let's actually talk about what constitutes a rational expression. A rational expression is the quotient, or fraction, of two polynomials. So we have a polynomial like we were dealing with in P5, and we have for the numerator and for a denominator. Two different polynomials. The domain, which is the set of all x values that work in the expression, in particular for polynomials, is all real numbers. For rationals, it'll be all real numbers that don't make your denominator 0. So our first question is to simply find the domain. So again, the domain is all real numbers except anything that might make the denominator 0. What makes the denominator 0 here? What x value would make the denominator equal to 0? 5. Right, if I put 5 right here, I'd have 5 minus 5. The denominator would be 0. That's no good. Why is that no good? Well, division by 0 is not defined. And the reason is because when you multiply anything by anything else, you can't get 0 back unless one of them were 0 to start with. So no zeros in denominators. So when we're writing this, there's several ways that we could write this. One option is that you can write this is all x such that x cannot equal 5. That's set notation. That's telling you that all numbers work except 5. You can write it in interval notation. We'll talk more about interval notation in a later section, but if you're familiar with it and you want to use it, it looks like this. It's all the values from negative infinity until you get to 5, and there's a parenthesis, union all the numbers from 5 until you get to infinity. So if you know how to use interval notation, you feel comfortable with that, I have no problem with you using it. If that looks a little bit weird to you, just ignore it for the moment and go with the first one. To be perfectly honest, if you wrote me a statement that said all values except x equal 5, I'd be okay with that too. Okay, you're describing it in words. Description in words is not necessarily a bad thing, so that's all right. So when we have denominators, we want the denominators not to be 0. If you take a look at number 2, number 2 didn't have a denominator, right? So what values can x equal here? Anything, right? There's no value that's going to cause a denominator to equal to 0 because there is no denominator. So on this one, you can write x is real. You can write negative infinity to infinity. You can write for me all real numbers. Any variety of that would work on problem 2. Now number 3 is a bit more interesting. Number 1 we could just look at and we could say, hey, 5. I can put 5 in for x makes the denominator 0. Number 3 is a little harder to see because it's not got just one x in it. There's an x squared and an x in it, right? So on this one, it's a lot easier to work with if I take that denominator and I factor it, because I could, potentially at least, factor it. So again, I'm going to use trial and error because that coefficient at the beginning is a 1. It's nice to do with trial and error, so I put an x here and an x here. The addition at the end means my signs match. The addition in the middle means they're both positive. So I have a positive here and a positive here. And then I need two numbers that multiply to 2 and add to 3. 2 and 1. There's actually only two numbers that multiply to 2, right? 2 and 1. So that'll do it. Now, it happens to be true, and we'll talk more about what we do with this later, that this x plus 2 and this x plus 2 will cancel out. But that doesn't have anything to do with my domain. This question simply asks me for the domain. And the reality is that if this piece, x plus 2, is equal to 0, I still can't have that as part of my domain because it would make the entire denominator 0. So what I want to do is I want to find out where each of these individual pieces is equal to 0. Whether you write that part or not is sort of irrelevant to me. They're very simple linear equations. So if you can just look at it and say, well, I just know that this is the value, kind of like we did on the one over here, and said, well, I just know that if I put 5 in for this, it would work, then that's great. If it helps you to see it written out, then write it out. So I would take a 2 away if I do it as written out. I would take the 1 away if I write it out. And the reality is that there's actually 2 places where this denominator equals 0. And if you wanted to confirm that you were right, you could take negative 2 and you could plug it into x squared plus 3x plus 2 to check. Right? And you could do the same thing with negative 1. You could plug it back in here to check. That's one way to check to make sure that you factored it correctly as well. So what's my answer? Well, again, we have lots of ways we can write it. If we go with that set notation, we would say x such that x does not equal negative 2 and x does not equal negative 1. That's one way to write it. You could say all real, if you're writing it in verb, like words, all real numbers where x does not equal negative 2, x does not equal negative 1. If you like interval notation, this one looks really messy, but I'll show it to you just in case that's you. You can do negative infinity to negative 2, union negative 2 to negative 1, union negative 1 to infinity. And again, if this interval notation is sort of blowing your mind, or it's just foggy enough that it's just not clear, just ignore it. You don't need to do that right now. All right, any questions on domain? So domain is all about the denominator equaling 0. No denominator, no problem. Denominator, you got to find when it's 0. Now, another thing that we're going to take a look at, much like I just talked about on number 3, is when it is that we're going to reduce or simplify things. So in particular, how do I take what's in rational form and see if that's the only way it can be written or if there's a simpler version? And the way that I do that is much like what I just did with number 3, where I just take that denominator and I factored it. So we're going to be factoring a lot in this section, and a lot of the factoring once we get here is simple enough factoring that you don't necessarily need the AC method or slide and divide. Trial and error works pretty conveniently because the factors are nice. Not always, but most of the time they are. So if I take a look at this one, I'm going to factor not just the denominator like I did on the last problem, but the numerator as well if it has the ability to do so. And this numerator does. Negative 2x minus 4. What's in common to both of those terms? Yeah, the negative 2. So if I take out a negative 2, I'm left with x. And negative 4 divided by negative 2 is positive 2. So that's the numerator factored. Now the denominator is a trinomial. So I'm going to use trial and error again because that coefficient at the beginning is a 1. Coefficients of 1 factored pretty cleanly. X squared gives me an x and an x. That's why I like factoring with trial and error when there's a coefficient of 1, is because I can already automatically get started. Now this one's different than the other ones we've seen because there's a negative 10 at the end. If it's negative, it means that one of the signs has to be positive and one has to be negative. I'll make that one positive since I just said it, and negative. So I need 2 numbers that multiply to 10. Okay, there's not a lot of options. There's 2 and 5 and 1 and 10. Those are my only options, right? And what I need for the difference between those 2 values to be 3. Why am I saying difference instead of sum? Well, because one's positive and one's negative. So their signs are going to be different. So what 2 numbers, 10 and 1 or 5 and 2, have the ability to subtract to the number 3? Yeah, the 5 and the 2. And I want -5, you're exactly right, and +2. And the reason is because I'm trying to get a -3. So the 5 has got to be the negative value. Good job. Now, here's the trick. The questions are set up because they're going to eventually, most of them, have something on top and something on bottom that cancels. So if you're needing some idea of, well, what might it be? There's probably an x plus 2 on bottom. It's got an x plus 2 on top. Right? It's kind of a red flag. I'm going to expect that that's going to happen. Maybe it doesn't always happen, but we're looking at like probably 95% of the time something's going to factor out. That's the goal. Otherwise, we wouldn't have asked the question. You know, maybe one in a whole set that's not going to factor out anything. So this one, of course, does. These are identical, so they cancel out, much like we have fractions and they both divide on both divide by 2 on top and bottom. We can factor out that 2, cancel it out. And so I'm left with a -2 on top and x minus 5 on bottom. That's reduced form for this particular problem. Any questions on that one? What factoring strategies do you see at play on number 5? Yeah, those are those special formulas that we used back in P.6. The top is the difference of cubes, and the bottom is the difference of squares. Okay? So we are going to apply those formulas. In fact, they actually look exactly like our formulas because they even have the A and the B in them like our formulas did. They wouldn't necessarily have had to do that, but this one did. So this is A minus B. And again, if you reference back to the formulas, you'll have A squared plus AB plus B squared on top. Difference of squares will be A minus B and A plus B. So that's the factoring that I see at play here. And what do you notice? The A minus B's cancel. So when I simplify this, I have A squared plus AB plus B squared over A plus B. Somebody on the first test, somebody on some quiz, somebody on some homework is going to try and cancel something out here that they can't. You're going to say, hey, look, there's an A here, and you're going to mark an A out. You're going to take one of those A's and mark it out of the top. You're going to see this B, and you're going to mark out a B, and you're going to mark out a B on top. You can't do that because they're not factors. They're terms. There's addition and subtraction in play on the top and on the bottom. So you can't cancel anything out that's added and subtracted to pieces. All right, that's not acceptable in the sense that it doesn't work. And if you guys were to look at it from a numbers perspective, right, like 5 minus 2 over 5 minus 3, you'd never do that. You just wouldn't. You wouldn't even think to do it. You'd combine the top, you'd combine the bottom, and that's the correct approach. It will give you the right answer. So you can't go canceling out pieces that are separated with addition and or subtraction when you're canceling like terms or like factors. Okay, a couple more things in this section. Multiplication and division. So multiplication and division are very similar to simplification, actually. So what we're looking for is we're looking to see what reduces. And the reality is whether it's written as it is on number 6 or whether I combine them on top like this. Like I can write 14W times 3W on top over 51y times 7y on bottom. All the numerator, all the denominator, whether they're all together there or whether they're separated into the individual fractions from the beginning, is the same thing. We could multiply the 14 times 3 and we could multiply the 51 times 7. The numbers will get very big, not very big maybe, but they'll get larger, right? So instead of letting the numbers get larger, it's actually a lot easier to reduce them when they're small. For example, you probably noticed the 14 and the 7. They're both divisible by something. It's easier to divide them out when they're small because it's easier to see that they both divide by 7. Right? 14 divided by 7 is 2. 7 divided by 7 is 1. It's actually true that the 51 and the 3 also divide out. Have you ever heard of the trick of multiplying or not multiplying, but values that divide by 3? Yeah, you're right, Caleb. If you add 5 plus 1, what do you get? 6. Is it divisible by 3? Then 51 is as well. It also works for 9s. That's how you know. 51 will be divisible by 3 because 5 plus 1 is 6, and 6 divides by 3. Grab your calculator if you don't know what that value is, but 3 divided by 3 is 1. What is 51 divided by 3? $17 is right. So then, what am I left with on top? Well, a 2. I have a couple w's, so that's w squared. On bottom, I have 17. And I have a couple of y's, so that's y squared. I cannot cancel out squared roots. We've talked about that on a couple of occasions at this point now. So I'm done. The numbers don't cancel, the variables don't cancel, and exponents never cancel. Oh my goodness, 7. Wow. Aren't you glad they aren't all like number 7? I am. You should be too. 7 looks terrible. There's several things to sort of mention on number 7. The first is that it's division. Division means that I multiply by the reciprocal. So one of the things that I'm going to end up doing is I'm going to switch the second fraction. It's always the second fraction. I'm going to flip it. Just one thing I want to bring up. The other thing that I want to bring up is that it's actually, I'll flip back over here, I promise. It's actually a lot like these, where I see pieces that have the ability or potentially have the ability to factor. So I'm going to be doing a lot of factoring on this particular problem. So we're going to take a look at that. These are not quite as straightforward with trial and error. I'm going to show you what they look like. But if you don't like trial and error, you can go back to the AC method or slide and divide or some other process that you like that you've seen before. That'll work. But we're going to factor. So I'm going to factor them actually right where they are, I think, to minimize some of the space that I'm using up. Hang on. So the first one, in order to get 3a squared, there has to be a 3a and an a. It's the only way I get 3a squared. I do have a -4 at the end, which means my signs don't match. I may not know necessarily from the beginning where those signs go. So that's the trial and error part of it. I'm just going to put them in, and I may need to switch them. I'm not referencing my notes. I'm definitely doing it arbitrarily right now because I have no idea. Well, I want to do it like I would really do it if I were doing it with you. Okay, I'm just going to put them in. So the numbers that give me 4 are either 4 and 1 or 2 and 2. And I just pick one and I try it if I'm doing trial and error. So let's say I pick 2 and 2. And what I check for is I check to see if when I do the inner and the outer terms, they end up with a positive a in the middle. That's what I'm checking for. So right now, the outer terms give me 6a, and the inner terms give me -4a. That's not the right value in the middle, right? Not going to work. So I'll backtrack, and I don't want 2 and 2. Now, normally what I do right here is I'd switch them, but 2 and 2 I can't switch because they are matching already. So my other option was 4 and 1. Okay, so let's put a 4 here and a 1 here and see if that works. And if it doesn't, we'll switch the location of 4 and 1. So let's check. On the outside, I get a positive 3a. On the inside, I get a -4a. What does that give me? Positive 3, -4, -1. That's almost what I want. Yeah. I don't want -1, I want +1. So I've got the 4 and the 1 in the right spots because I got the right numerical value. I just have the wrong sign. So when I have the wrong sign, I just need the signs to switch from what I guessed that they were to start with. And then if I recheck, they should work. Now I have negative 3 on the outside, and I have positive 4 on the inside. Does that work? It does. This is now factored correctly. That kind of helps because I'm probably going to expect to see either the 3a plus 4 or the a minus 1 show up somewhere else in a numerator or denominator for reducing. So it gives me a little bit of a clue for the other ones. Okay, let's go on to the denominator. We're just going to work our way around. I don't especially love the fact that the a, actually let me take a step back, that the a, well that this is written backwards, I should say it that way. And by backwards I just mean that the a is at the end instead of the beginning. I don't really like that very much. I'm going to rewrite this, but notice that the a itself has a negative 2 in front of it. That's also not very nice. We mentioned that before when we encountered a negative on a different problem at the beginning, and I said let's pull that negative out. Makes it harder to factor if it's there. So it isn't that you can't factor this like this, it's just that it doesn't match our pattern that we were doing very well if I do. So what I would like to do is I'd like to pull a negative out, and I'd like to rewrite all the numbers so that they go in descending order of exponents. So I'm going to write my 2a first. If I pull out a negative, I want to have a positive a, and I will have a negative 15. So I need to not lose this negative, of course. But now this, oh, sorry, that's 2a squared. Left off the squared. This piece right here looks a lot more like the other ones that we've done. So let's take a look. There's a negative pulled out. I'll have 2 sets of parentheses. 2a squared means I'm going to have a 2a and an a. It's the only options I have. Negative here for the negative 15 means one's positive and one's negative. Again, I don't know which way they are. I'll just put them in there and we'll check. 15's not terrible, kind of like 10 was not terrible, and 4 is not terrible. There's only a couple of options. 15 and 1, which seems like it's probably not going to be the one I want, right? It's going to create big numbers, and I don't have a big number here in the middle. I have a small number. So instead of 15 and 1, I think I'm probably going to go with 5 and 3 as my starting place. I can always use 15 and 1 later if I find out I'm wrong. So let's try 5 and 3. I'll put a 5 at the beginning and a 3 at the end. And we look at the inner and the outer. My outer, the 2a and the negative 3, is negative 6. The inner is positive 5. I'm really close. What do I need to adjust? I need to flip the signs. You're right. I've got the right value. I need to flip the signs. So there should be a negative here and a positive here. Okay, now none of that matches what's up here. Agreed? So I don't have any reducing within this fraction itself. So I got to be hoping there's something over here to reduce, right? I mean, like, let's be real. Got to be hoping. So we're going to factor these two pieces as well. I'll rewrite all of this in a moment where I flip it. I think I'm going to need some space, so I'm actually going to take this out for the moment and just shift this up so I have more space. So these are the factored pieces. All right, let's take a look then at the 6a squared minus 7a minus 20. This one's not nice because this is the first time I've encountered it, right? But 6a squared means I could have 6a and a or 2a and 3a. And I don't know which one I want. But if you take a look at the things that we've already done over here, the 2a and the 3a seem like they might cancel with something I already have. So I'm kind of going to go on a hunch that I'm going to want to split it that way. So we're going to go with 2a and 3a because it matches something, maybe. Or at least it stands a chance. The sign's negative 20 at the end, so I need a negative and a positive. 20. Well, it's 1 and 20, 2 and 10, or 4 and 5. Well, I got 4s and 5s here, so I might want to try that. possible, right? So let's see. If I have the 2a, it matches the 2a minus 5. So, I mean, that's as good a place to try as any. And then I'd have a positive 4. Okay? So the 2a minus 5, the 3a plus 4. This is a good thing to check. It seems like a reasonable thing that might cancel. So let's see if we got the middle terms to match. On the outside, I have 2a times 4. The numbers are what I'm most concerned with. 2 times 4 is 8. And on the inside, I have negative 15. So I have a positive 8 and a negative 15. What do they add to? Negative 7. Okay? So try to think like you're thinking through a puzzle on these. What would be most convenient for it to be? And let's see if it works. And it did on this one, so that was nice. Let's try the same thing for the other one. 2 factors. Again, I can do 4a and a, or I can do 2a and 2a. I don't have anything here that says 4a, so I'm going to try the 2a and 2a because it seems like it might be something that would cancel, so maybe it's going to factor that way. If it doesn't, we're going to adjust and we'll change it back to 4a and a. On this one, I have a positive 25 at the end. I promise I'm just 2 seconds from being done, okay? The positive 25 at the end tells me that the signs have to match. The negative at the middle says that they need to be opposite, or need to be negatives. The 2 numbers that are going to work here, I'm going to spoil all the fun and tell you that they are 5 and 5. Now, remember, we have to change the orders on these. So I have 3a plus 4 times a minus 1 over negative 2a minus 5 times a plus 3. And everything that's on the denominator here, the 2a minus 5 and 2a minus 5, are now in the numerator. That numerator, which was 2a minus 5 and 3a plus 4, are in the denominator. Okay, so I switched these because it's division. Division is multiplication by the reciprocal. And now I'm looking for pieces that cancel. So 2a minus 5 cancels. 3a plus 4 cancels. And this 2a minus 5 cancels. On the top, I have a minus 1. And on the bottom, I have a negative out here. Don't forget him. And a plus 3. And that's the simplification for that one. Obviously, we are not finished with this lesson. So the good news is you won't have it due on Tuesday. The bad news is on Tuesday, when we finish this lesson and we move on into P7, which I think is our next one, you very likely will have 2 lessons due on Thursday. So my advice to you is to accomplish as much as you can in section P6 right now, even though it's not due on Tuesday, and I'll adjust it in Canvas. Yes, Anya? What's that? It is, so the quiz will have to move to Thursday. Thank you for reminding me. Yes, so we will also move the quiz to Thursday since we're not finished with P6. Thank you so much. Awesome, so P5 is due on Tuesday. P6 will shift to Thursday. And it would be a good idea for you to start working on that so you don't have 2 lessons due between Tuesday and Thursday. Have a great weekend, guys.